Bajo sea nomads. Imagine you could hold your breath for 13 minutes straight. Imagine freediving to 60 meters, seeing things at depths most people only reach with scuba tanks. Sounds like a superpower, right? For the Bajo sea nomads of Southeast Asia, it's just Tuesday. Their secret? They have spleens up to 50% larger than average. Your spleen is your body's natural scuba tank. It contracts during dives, flooding your bloodstream with a surge of oxygenated red blood cells, literally giving you extra oxygen when you need it most. It's a built-in dive response optimized by genes like PDE10A and BDKRB2. While you're gasping for air after a quick dip, they're exploring the ocean floor like it's their backyard, without a single piece of equipment. They didn't train for this. They were born with it, Tibetan Highlanders. You take a trip to the Himalayas, and within hours you're lightheaded, nauseous, and panting for breath. That's altitude sickness. For the Tibetan Highlanders living at 4,500 meters, that's just Tuesday. Their superpower is in their blood, or rather, what isn't in their blood. Most people at high altitude overproduce red blood cells, which sounds helpful, but actually thickens the blood, making it dangerous. Tibetans, however, carry a variant of the EPAS1 gene inherited from ancient Denisovans. This gene prevents that dangerous overproduction, allowing their bodies to efficiently use the thinner air without risking stroke or heart attack. It's one of the fastest spreading genetic adaptations ever recorded, letting an entire population thrive where you'd barely survive. Your body panics, theirs just shrugs. Andean Highlanders, the thin air of the Andes, much like the Tibetan Plateau, should be a problem, but the Andean Highlanders solved the same challenge of high altitude through a completely different evolutionary route. While Tibetans adapted their blood production, Andes went for a more direct approach, bigger lungs, higher hemoglobin levels, and elevated nitric oxide for better circulation. They haul more oxygen with each breath and pump it through their systems more efficiently. It's a textbook case of convergent evolution, same survival problem, totally different genetic solution. Your body struggles with one problem. Theirs found two ways to fix it. Ethiopian Highlanders. Just when you thought high-altitude adaptation couldn't get any more varied, meet the Ethiopian Highlanders. They live at around 3,000 meters and thrive, but with yet another unique set of genes. Unlike the Tibetans' red blood cell regulation or the Andeans' lung capacity, the Ethiopian adaptation appears to work at the cellular metabolism level. Their cells extract energy from oxygen more efficiently, almost as if their internal engines run on less fuel. It's a third independent solution to surviving thin air, proving that when nature needs a superpower, it has infinite ways to invent one. Your cells starve, theirs feast on less. Inuit Arctic peoples. Imagine living on a diet of almost pure animal fat. For most people, that's a recipe for heart disease and clogged arteries. For the Inuit and other Arctic peoples, it's been survival for millennia. They carry a CPT1A gene variant that allows them to metabolize this extreme diet without cardiovascular damage. Their bodies are specifically wired to process fatty acids, turning blubber into fuel with incredible efficiency. But it's not just their diet. They also produce more body heat through brown fat thermogenesis, essentially a built-in heating system. While you shiver, they're generating internal warmth from a diet that would kill you. Your metabolism complains. Theirs thrives. West Africans and descendants. Malaria is one of humanity's oldest and deadliest foes. But some West African populations and their descendants carry a secret defense. They possess one copy of the sickle cell allele. If you have two copies, it leads to sickle cell disease. But with just one, your red blood cells are subtly distorted, just enough to make them hostile to Plasmodium falciparum, the deadliest malaria strain. The parasite can't replicate effectively, giving you strong resistance without suffering the disease. It's a classic heterozygote advantage. A genetic mutation that's harmful in one form becomes a powerful protector in another. Your blood is a welcome mat. Theirs is a trap. Duffy null populations. Here's another anti-malaria superpower. Many populations in sub-Saharan Africa are Duffy null. This means they have a variant in the ACA1 gene that removes the receptor that Plasmodium vivax, malaria, uses to enter red blood cells. No receptor, no entry. This grants near-complete immunity to that specific malaria strain. It's like having a locked door with no keyhole. The deadliest version of the parasite just can't get in. You rely on nets and vaccines. They rely on their DNA. Northern Europeans, you enjoy a glass of milk or some cheese without a second thought. But for most of human history, and for most people on Earth today, that would cause cramps, bloating, and discomfort. Most humans lose the ability to digest lactose after childhood, but in Northern Europeans, a specific mutation keeps the lactase enzyme, the one that breaks down milk sugar, switched on into adulthood. This lactase persistence spread explosively around 7,500 years ago alongside cattle farming. You take this for granted, but your ability to enjoy a late-night ice cream is a relatively new genetic superpower. Your ancestors adapted to dairy, others' stomachs just can't handle it. Yupik Siberian peoples. Surviving the brutal cold of Siberia and the Bering Strait requires more than just thick clothes. The Yupik and other Siberian peoples have enhanced cold weather thermogenesis. They generate and retain body heat more efficiently than most populations, thanks to adaptations in fatty acid metabolism. Their bodies burn fuel more effectively to sustain core temperature in extreme cold. It's like having an internal furnace that just runs hotter, keeping them alive in conditions that would cause rapid hypothermia for others. Your body shivers. Theirs just turns up the heat. Greenlandic Inuit. Building on the fat metabolism adaptation, Greenlandic Inuit possess additional cardiovascular and lipid processing genes. These protect them against heart disease, even on a marine diet. Extremely high in omega-3s and animal fats, their bodies are essentially optimized for a diet that would be dangerously extreme by any other population's standards. It's not just that they can eat fat, they can process it in a way that actively protects their hearts. Your diet causes problems. Theirs became their superpower. Solomon Islanders. In the Solomon Islands, you'll find a surprisingly high frequency of naturally blonde hair, but it's not related to the blonde hair mutation in Europeans at all. Solomon Islanders carry genes from a mysterious, unknown archaic human population distinct from Neanderthals or Denisovans. And their blonde hair comes from a completely independent genetic pathway involving the TYRP1 gene. It's a unique superpower, a familiar trait achieved through an entirely different and ancient genetic lineage. Your blonde hair has one story. Theirs has a secret origin. Sherpas. When it comes to conquering the world's highest peaks, Sherpas are legends. While they share the EPAS1 gene with Tibetans for altitude adaptation, they also have another layer of superpowers: mitochondrial adaptations. Their cells extract energy from oxygen even more efficiently, meaning they produce more ATP per breath than lowlanders, even at extreme altitude. It's not just about getting oxygen, it's about making every molecule count. Their bodies are super-efficient energy converters, giving them incredible endurance in the death zone. Your cells struggle. Theirs are supercharged.